Hello everyone, my name is Wyatt Wells, and today I'll be presenting to you the Algae Estimator on behalf of the Algae team. So the Algae Estimator is both a Android and iOS app that we created with the goal of making information about algae blooms and algae in general more accessible and easier to use for the public. And for this project, we worked together with Dr. Sander from Ostweiler University in Wolfenbüttel, Germany. And she actually approached us about starting this project. It was her idea, and she provided us with all of the necessary formulas and biological information to make this happen, because all of the developers on this app, including myself, are undergraduate computer science students with little to no background in biology. Now, doctors and other experts in biology have access to instruments that allow them to accurately predict algae blooms and measure other data from freshwater lakes. However, Dr. Sander brought to our attention that these instruments are very expensive, they require training to use, and simply aren't really feasible for the average user to use. So we wanted to create an app that we can accurately, within reason, obviously our app is an estimator given the name, but we want to reasonably be able to predict harmful algae blooms, or colloquially HABs. Now, why would somebody other than a biologist like Dr. Sander want to have access to this information? Well, HABs can be harmful, extremely harmful to local freshwater ecosystems. They can deplete water of oxygen, making it really unsustainable for other life, especially animal life and fish life. And some of the algae blooms can be toxic, which these toxins released by these species can be extremely harmful or even deadly to animals and humans. So this information and putting this information in the hands of a wider reach of people can be very beneficial for not only scientists, but people who perhaps are looking to just enjoy their local freshwater systems, or farmers and the like. So for this project and the development, we use the Algae Scrum development process because we really just deem that to be the most efficient. And within the overall algae team, we had 3 sub-teams working on iOS, which includes Jose and some previous team members who are no longer on the project. Alan and myself worked on Android, and then we had an API team who was led by Antero. Currently, Jose is our Scrum Master, and we work in 2-week sprints. Overall, I'd say we work together pretty well as a team, and we haven't had a lot of barriers in communication or anything like that. Obviously, that's pretty hard to quantify and show on paper, but just for personal experience, I think that's important to add. For backlog and documentation, we used Atlas Jira. All development team members were able to assign user stories and subtasks and log time on said tasks. Microsoft Teams was our main communication platform, used for chat messaging, posting meetings and general information, as well as video and voice conferencing, which has proven to be a quite necessary tool in the tumultuous times that we're currently in. Overall, this platform allows for really efficient communication within our team, which is very important for efficient development. Now, getting into the meat and potatoes, the app itself and the design approach. Firstly, we have a login screen, which that login is stored by Firebase. And then when the user logs in or creates an account and logs in, they are brought to the home screen, which is shown on the left here. And then we also have a hamburger menu, which is pretty much just a smaller version of this home screen on the left that has the same options and buttons. And in addition to the main view input data, which is sort of the main feature of this app, where you get the estimations and whatnot, we also have some other features like the visual estimate feature, which basically allows the user to look at some pictures of some examples of what potentially harmful algae might look like. We also have the About Algae tab, which just provides some general textbook type information for the users, and the map feature, which allows the user to see some other input as well as their own input on a user-friendly Google Map platform. As you can see in the pictures in the bottom right, these nodes are color-coded based on safety, and This allows for a reasonable sharing of information, but we'll get more into that in a later slide. So data input, this screen you see on the bottom left is the initial screen that you're brought to when you click on the data input button on either the home screen or the hamburger menu. This allows the user to input various data. Firstly, phosphorus levels, where the user can either directly input a number if they have the tools necessary to collect that information, or the app can generate an estimate based on the landscapes and type of land in the area. Also an estimate based on the quantity of plants in the lake and the frequency of algae blooms if the user has that sort of information. These are obviously quite vague data points, but it's the best that we can do if the user doesn't have access to tools to accurately measure phosphorus levels. Water surface temperature, which is just the temperature of the surface of the water. Water bottom temperature, which is the temperature of the bottom of the water. Lake depth, which is pretty self-explanatory. Brightness, which is measured in lumens, which the user can either put in manually or the app is also set up to automatically measure that through the camera as the user is just pointing their camera around. And as that brightness changes, as you point the camera in a new direction, it will automatically change that value. And then that value is finally submitted when the user clicks the submit button, Now for the chlorophyll levels, similarly to the phosphorus, the user can either put in a direct measurement based on both the total chlorophyll and the cyanochlorophyll if they have access to the equipment to measure that, or again they can have the app make an estimate based on Secchi depth and dissolved oxygen in the water. And lastly, they can input the air temperature. Now obviously these things generally require tools and instruments to measure, but the tools necessary to measure these things should be, or at least the idea is, based on Dr. Sander, that these tools should be a lot more accessible to the everyday person than your multi-$1,000 machines that generate all this information automatically. Also, there's some small help buttons. If you see the question marks on the right-hand side of the screen, these pull up a smaller menu that will help guide the user in making these measurements and whatnot. Then once you hit the submit button in the bottom of the screen, it will take you to take a photo of said body of water. Now this is both for personal reference, but also for the reference of others if they were to click on the map icon for this image, or for this entry, this just provides reference for everybody to make things a little bit easier. And also you can give sort of a visual estimate of what the algae in the current situation, that body of water, is. Then once you accept your photo, the app will ask you to name the entry, pretty self-explanatory, and then it will bring you to this screen on the right, which allows you to view your data. So the name of this entry, for example, is Lake Michigan. Now the user can choose to be this vague, or they can be more specific if they choose to. Right below that, it shows whether the location or not is safe or not, and this text will be color-coded as well, just for ease of use. And the photo below is the photo that was entered with the entry. Below that is the date, as well as some of the data that was necessary in the calculations below. I could go deeper into that, but and more of the things that are listed below that, but honestly it would probably go over my head as it would yours, as we're not biologists. Then if you scroll down further past the data, you will see the graph, which is in the bottom right-hand corner of this slide. This graphs out the chlorophyll levels in relation to time, and this is supposed to be a prediction of how these chlorophyll levels will change, and be a prediction for whether or not a algae bloom is likely for the near future. So this is the real important part for the users, because they can see then if a algae bloom is likely in the near future, and then they can take precautions, i.e. avoid swimming, fishing, etc. Now, this screen can also be accessed from the data log, which is shown in the top right here. This is simply just a list of all the previous entries that user has made, with the dates on the left and the names on the right. They can click on any of those entries and it'll bring up the same screen. Now, if we backtrack a bit to the main screen and we click on the visual estimation section, this is the screen in the bottom left that comes up. Now, this allows users to look at these different pictures and click on which image most suits their body of water. Now, this is not intended to be a very accurate estimate. This is sort of just to provide some general information for the user. So for example, if you click on the top picture, which is supposed to be an example of potentially harmful algae, it'll pull up the screen that you see on the right there, give some information about it, and also recommend that the user inputs their own data for their own body of water if it looks like that, as that could be potentially harmful. The About Algae tab is probably, it doesn't have a lot of bells and whistles, but it's a pretty important tab, I believe. This provides lots of information for general users who aren't biologists. They can read through all of this information. It's basically like a frequently asked questions kind of section, where they can see lots of information about algae blooms, and the reason why it can be dangerous. And you can read more on the right if you're interested in what other sorts of questions that tab answers. Now, if we backtrack a bit to this slide, I'd like to talk a little bit more about the map. I summarized the intention of that earlier, but basically the idea of this is to be able to share information and share entries. As you can see, the multicolored nodes on the bottom right-hand corner, those are supposed to indicate safety levels. And then if you go further right, you can see the other screen, which shows up the filters. And these filters are applied in the backend to allow the user to sort through the data more easily, to find what suits them, or just in general what they want to find. And as you can see, you can arrange by most recent, safety, distance, etc. And speaking of the backend, for this app, for the database implementation and the API, we use the backend service Firebase, which is a Google company. This service is available for both mobile and web applications. This allows us to use user registration and account management, as well as our real-time database very easily, and it all flows together really well. As somebody who doesn't have a lot of experience with backend and databases, it was pretty easy for me to implement. And everything's put together in one place with a lot of pretty user-friendly tools. And I think that's overall a really good service for a lot of small-scale projects, because you don't necessarily need a dedicated backend team. We did have this luxury, however, and Ontero set up an API for us, which will help us limit the API calls, since that's a limitation of the free service. I believe there are upgrades available, but I'm not familiar with them. So all of the data that you've seen from the data input earlier is stored in the real-time database in Firebase, as well as any data input by the user itself can also be stored in a local database, which is obviously different from Android and iOS. Our API was built using Node.js, and we used Google Cloud Storage to store the photos, which integrates really nicely with Firebase. So challenges. There was a lot of challenges with developing this project, as it was started by another group in 2016. So when we were handed over the project, basically what was completed at that point was pretty much just a proof of concept of the main feature. The project was buggy, the software was out of date, the Xcode and Android and Swift versions all needed to be updated. Some of the bugs included, I believe the iOS version didn't really work at all until iOS was updated, and updating it, I believe, changed some syntax and whatnot. So the first couple of weeks were just sort of debugging and getting familiar with the apps ourselves. Also, the initial project wasn't documented really at all, so navigating some of the code was really difficult. And as we were trying to add new features, this made it pretty difficult trying to integrate this with the old code. Also, the project specifications and our expectations were changed many times over the course of the semester. Initially, the project was just to update the UI. We were given a Xcode file with a bunch of screens to update, and then we quickly learned that Along with those screens, we needed to add more features, such as the map feature, the About Algae tab, the estimation. And although the estimation and the About Algae tab are pretty straightforward, we then learned that we were going to be using a Firebase database instead of just local database, which was what was used before. As the old app didn't use any remote database, it just saved the data to the phone, and then the user could access that data. We wanted to move to the Firebase database, not only to reduce the load on the phone itself, but then we can also integrate our map feature and share that data with other users. Also, for many of us, there was a big learning curve with some of these features. It was personally my first time dealing with anything with Firebase, so there's a learning curve there. Overall, I think the project turned out pretty well, but there was some challenges, especially I'd say the biggest ones was the lack of documentation with the old code and trying to implement that into our new features, and also the changing of specifications. Constantly, our specifications were updated throughout the semester, adding or changing features. But this is why we use the Agile and Scrum development process, as the traditional waterfall method just would not be adequate if we wanted to change the specifications so frequently. So in conclusion, we believe that this application is an important tool for the public to be informed about water safety, as this is sometimes something that's overlooked, and in general, the tools for this sort of thing aren't generally available for the public. So we wanted to provide a platform that was easy to use, provides entry-level information so that this can be available for people who do not have a background in biology, and they can be aware of the risk. We allow users to create an account, store their experiments in online database, and calculate this data and share with others via the map. We think this application could be useful for both everyday people and also professionals and biologists around the world. That's all I have for today, so thank you for listening.